Hi, my name is Aditya, and in this video we will be designing Instagram. Instagram is a very popular photo sharing application that allows users to upload and share photographs with one another. Before we get started, let's think about a few use cases of our system. Users need to be able to log in to our system. Users should be able to upload pictures. Users should be able to view pictures, and viewing can actually be broken down into three sub-use cases. So we can say one of them would be just browsing. Another would be view their own home timeline. And a third we could define as viewing the pictures that they themselves have uploaded. So this would be own timeline. Some other features, some other use cases we have is following users. So following actually interacts with the home timeline, which is the timeline where once you open up the application, it takes photographs from all the people that user is following, and it shows it to the user. And some other use cases could be comments, likes, as well as sharing to other media. So share outside. So let's get started. So let's think about how we can model how we can model our system. So we have users. So this is a user. This is our system. User first interacts with the login. We use login use case. Once logged in, the user, this is, let's say, upload. Let's say this is viewing here. Viewing, and then viewing gets broken down. So we can say this is own, this is home, and then we can say own, home, and then just browsing. And then following also can fall under here, so we can say from viewing we can follow as well. So this is follow. Okay. So let's think about how we can represent our users. So one way to represent our users would be, think about the attributes of what we would like to store. So a user, we have a user. User could have attributes such as name, age, let's see, last login, location, last login location, so last location. So we have name, age, last login, username. So that's how we can think about a user. We can also, so we have our users. On Instagram, we also have pictures, so we can represent our pictures as well. So we have our image. This is our image. It's our user. Our image will have, for example, like we can store file name, size, update, uploaded, file size, date uploaded, as well as we can think about an image ID. So this image ID would be unique to this image. And with each image, we have to associate a user because a user uploads an image. So we can also define a user ID here. So So this is a user ID, this name, and within the users, we have a user ID. So these are unique to, this user ID is unique to each user. This image ID is unique as well, but multiple images might have the same user ID because one person could upload 4, 5, 6 images. So here we would have a one-to-many relationship. Okay, so that's how we can think about modeling our users, modeling how images are represented within our system. So now we haven't talked about how to model interactions, between users. So one way to model this relationship would be to say we have a map where we are going to store a user ID. So this would be one user ID, and it would map to a list of user IDs. So this would be a list of user IDs. So this would say that each user here follows the user here. So if this is A, and we have B, C, and D here, we can say that B follows A, C follows A, and D follows A. So that's one way we can represent a relationship. Now let's go back to our use cases here. So we've modeled our system. Let's think about our own personal timeline use case. So this is when you upload a picture and you want to be able to see your own picture on your own personal, on your own timeline, on your own timeline. So here, what we can do is say, each picture you upload, it has the way Instagram works is that it's sorted in chronologically descending order. So the picture that you uploaded most recently would be at the top. So what we can do is that, so this is one store we have. We can also make another one where we would just say, let's go from user ID to list of image IDs. Image IDs of this user. So this is saying, let's say if user ID A has 10 images, these image IDs would be the images that this user has uploaded. So what we can do then is say every time someone wants to look at all the pictures they've uploaded, we can look through this list and query for all the images based on the ID, because that's unique to each image. Using that information, we can show this user the pictures they've uploaded, and we can actually keep this in descending order. So that descending order by time, because like I mentioned earlier, we need images to be images. If we want the most recent image, so that would be the latest time to be in the front and the oldest time to be towards the back. So that's how we can think about this use case right here, so our own timeline. Let's think about the home timeline now. So the home timeline is where you have user A, let's say this is user A. User A is following, let's denote following with these lines. So he's following B, C, and D. So now user A is following users B, user C, user D, and these are the user IDs. So now for user A, we want to show user A his own timeline, or his home timeline consisting of pictures from B, from C, and from D. So right now, what we have is in this mapping, we had a list of this user and a list of user IDs that follow this user. So excuse me. So what we can do, so if we're following this model, what we'll have is we'll say B's list has A, C's list has A as well, D's list has A as well. So here, so this mapping doesn't seem to be useful to us because we can't figure out that A is, following all these people. So another approach would be to say that instead of having this map, we can have another one where it's just, user ID to people, to a list of people they follow. So this would be user ID, and we could say this is following IDs. So this is following IDs. This could be follower IDs. So we can maintain our difference this way. So if we have this, right? If we have this mapping from user ID to following IDs, we can do a lookup and we can say, okay, user A follows B, C, and D. Since user A follows B, C, and D, we can query this table, or if we represent our this user data and image data in some sort of a relational database, we can do a query saying, okay, for every user here, every user ID here, find me all the pictures that user ID has, and then show them to me. Show user A the pictures on user A's timeline. So that's one approach. That's one approach, but what happens is that if user ID A, for example, is not following 3 users, but let's say they're following 1,000 users or 2,000 users, or even more, we want the response time to see the home timeline and have all the pictures ready to give to user A fast. We want low latency. So if we do it this way, this is a more pull-based approach where at runtime we want to generate the home timeline at that point. But that could potentially be slow because you're doing these joins. You're figuring out which pictures from each user to give to user A for user A's timeline. So there's a lot of computation happening then. So that seems slow. So what can we do? We can actually think about it the other way, where instead of having user ID A just filled with the people this user is following, the IDs of the people this user is following, we can actually make a push-based approach where if we had this structure where we had this structure before, right? B to A, so this is the follower list. So B would have A, C would have A, right? So what we can do here is the exact opposite. We can say, hey, instead of user A pulling to get their timeline, we can just push. So anytime user B uploads a picture, user A's map already has the pictures that should be shown to user A. So they don't have to figure out pictures from each user, get the most relevant picture, and then show it. So what I'm saying here is that if we do a more push-based approach, we'll have, instead of having this table or this map, we can say, we can go from user ID to list of image IDs. List of image IDs for home timeline. So timeline. So here we can, we will already have the image IDs, and we can just figure out what image it is and show it to the user. So what are some potential issues with this approach? Well, one potential issue with this approach is that let's imagine that user B is a celebrity. Celebrity. Right? If user B is a celebrity, like Michael Phelps, Miley Cyrus, someone like that, user B will have, a lot of followers. Like this table could be millions. Millions, that's a large number. So if every time the celebrity B posts a new picture, it has to propagate to all the mappings for all the followers for B. which would be computationally expensive. So this approach has that downside. So how can we, address this issue? What we can do is have a hybrid approach where if a user, this user here, if this user is following, let's say, in this table, in this map, if a user is following what we call celebrity users, or users with a lot of followers, we can pull their images at runtime, but everybody else's who's not a celebrity, we can follow the push-based approach. So that way we have we combine the approaches, so it's not. So we don't have this fan out problem where one image is being added to the lists for all million users, but at the same time this list is not that big. So to summarize, one approach we can follow is that for each user we will maintain two mappings essentially. Two mappings. One would be, so we'll go from user ID to celebrity IDs. Okay, so celebrity IDs. What are celebrity IDs? Celebrity IDs are the users which have millions of followers. So this is again a followers list. Okay, we have a followers list. In addition, we will also have user ID to this list of image IDs for home timeline. So we'll have a user ID, home image IDs. Okay. Home image IDs, which this is going to get propagated this way, where we have, let's say C posts an image. This image would get pushed into this list. When user A wants to see their home timeline, we combine, but we do the joins and the pulling for the celebrity. But for everybody else, all the images from everybody else that's not a celebrity, we follow this approach. So that's how we can combine, both the pull-based and push-based approach. So now we have talked about how a user can see their own timeline, how the home timeline would work, and then in addressing the home timeline, we've also touched base on the following, so we can check that off as well. So now let's think about how we can do the uploading, right? So an app like Instagram is very read heavy, meaning when you get on the app, more people want to see pictures of others than to upload their own pictures. So if we go towards a more architectural design, we would want, thinking about this, we would want to split our functionality between uploading and viewing differently. Why? Because uploading is a more intensive process. It takes longer to upload a picture than to just be casually viewing pictures. So we would want to split the we would want to split the duties like this for that reason. Let's see. So we have that. So now let's think about how. So this is the So let's think about how we can store the actual picture, right? So right now, all we've talked about is the metadata about the picture, right? We've talked about file name, the size, date uploaded, image ID, user ID. But how do we store the actual picture? So one important aspect of this is that once a picture is uploaded, it's not really modified. Like, it's just there in our system and someone can view the picture. So what we can think about is one storage solution we could think about is using HDFS. So this is HDFS. So the Hadoop file system. So what advantages does this give us? One good aspect of this is that it will store all our image files on a distributed set of machines, which is fault tolerant. It has replication, meaning if an image is uploaded to our system, it's not it doesn't disappear. The image isn't lost forever. So HDFS provides all those benefits. In addition, because we have our entire system here is write once, read many, meaning once the picture is uploaded, we want to read, we're just going to keep reading. So HDFS is also good for that, because it's also good for that reason. So that's one possible way to store our images. So in addition to having just file name and size, we can also add like file path. And that could point to a file system here which stores the actual file. That's one way to approach this. Another thing to think about is that making use of CDNs. So having these pictures stored on machines that are closer to the user, so that the access times are quicker, like to fetch the image, show it to the user. So that's another approach. One downside of that is that if we use a CDN, we can't store every single picture that's been uploaded to our system on a CDN, because it could get financially expensive. So that's one downside of that. So we would have to come up with a policy of figuring out what pictures do we store in our CDN, what pictures do we not. And we can tackle that problem in a variety of ways. We can think about some caching solution, or some criteria of how we're storing images in our CDN and how we're storing the rest of the images in HDFS. So that's something to think about as well. So we've talked about uploading, viewing. So we can also talk about comments and likes. So likes, that would be, you could implement it this way. So you have a likes count, for example. So this would just be, an integer being stored into our database. In our database that just says like, okay, this image has been liked that many times. Comments is interesting as well, because what we can do is perhaps have another table. So this is comments, and within comments we would have users that are let's say users that are writing comments. So for comments table, I think we would have something maybe like, let's say we have image ID, user ID, and the actual text. So this could be user ID, comment, text. So this would, this is how we can think about storing the comments. So that's one way to do it. Yeah, thank you for watching.